You'll be all right. You'll be all right. Who's absent today?
Grace and Sam.
And who was the second one?
Sam.
I knew about Sam. Didn't know about Grace. All right. Homework. Get it out. It was 8-6, 5 through 6. No.
It was easy.
It was easy, wasn't it?
Yeah.
It was too hard. I couldn't get it done.
Well, luckily for you, I never forget to put zeros in the grade book.
I know. I've done my homework. I only missed two of them. I'm gonna do it. I'll find out what's up.
All right. Sarai, how many days did you miss? Just one. Okay. Homework last night. Make sure you turn in the previous thing today in the basket. Yes, Jake. Where is it? It's got a cover on it, right, Jake? It's got a cover on it.
Yeah, there's cover on it.
All right, cool. All right, any questions? Period 1 had no questions either. They said it's very simple. Okay, good. Here we go. Number 5. I'll give you both the letter. If you put the letter, and I'll give you the equation. All right, Ava, no homework?
I have mine. I put it in.
All right. Number 5, the answer is B. That's 24 plus x equals 84. You didn't have to write the equation. You could have just put B. Number 6 is C. That's x minus 24 equals 84. Number 7 is A. 24x equals 84. Number 8 is D. Delta 84 minus x equals 24. And number 9 is E. The only one left.
Wait, what was 5 and 6?
B, C. All right. Number 10. Now, remember, addition is commutative. Nathan, put it away. Addition is commutative, so it can be written either way. Subtraction and division is not, so they require a specific way of writing, but addition or multiplication can be written 2 different ways. So number 10, 3 plus n equals 15, or n plus 3 equals 15. Number 11, the only way it can be written. N minus 6 equals 17. Number 12 could be written as n plus 12 equals 40, or 12 plus n equals 40. Number 13 is 5n equals 80, or n times 5 equals 80. Either one's fine. Wait, that was the last one? No, 3 more. All right, 14. 5 plus 3n equals 30, or 3n plus 5 equals 30. Either one. Number 15, n plus 2n equals 24, or 2n plus n equals 24, either one. And the last one, 3n is equal to 8 plus n, or 3n is equal to n plus 8. Yes? 10 was 3 plus n equals 15, or n plus 3. 3n equals 8 plus n. I didn't think I went that fast. N plus 2n equals 24. This was that question we literally had in class. I just put an X on it. It was the same question. Like literally. Yeah. Go for it. All right. That was it. Somebody grab an empty basket over there. I thought I had the sheets up here. Didn't I?
Grade on correctness, or just like,
Say again?
do you grade on correctness or like completion?
Homework is always completion. Well, on worksheets I do, but like last night. Homework. All right, everybody hush, hush. So you guys aren't listening, you're talking. The comment that I got yesterday during the class was, after you wrote the equation, everybody said, do you want me to solve it? So yesterday I said no, but today the answer is
Yes.
it's the same class. It's a bit more challenging because the work problems are a bit longer. Same class, except today you will actually solve the equation. Most of these, Jay, most of these are one-step equations, so even easier. A couple of them are 2 steps, but most of them are one-step equations. We will be doing a total of 7 of these. I'll show you one example, and there are 6 on the sheet of paper. I'll just say on the level of challenging, not challenging, I'm going to have 2 people. The kids that are average to above average, this will not be challenging. For the kids that are not, a lot of times these word problems are very challenging, and you will see them struggle. I'll ask them questions, and they will be, I don't say use the word clueless, but they will not have a frame of reference of where to go, of how the brain should think about these problems. So my goal is to help those kids. For those of you looking at the problem like, I know what to do. Good, do it. I will warn you, however, the instructions say, don't tell me the answer. The instructions say, write the equation and solve it. So yes, you will write an equation. Yes, you will solve it. So even on the ones that you can just look at and say, oh, I know the answer is 14 or something. They want you to write an equation and solve it. But yes, I'm going to spend a lot of time today trying to help the people that always struggle with word problems. So I need you, if you're one of those persons, to not sit there and say, I have no idea what's going on. I need to ask questions. Okay. We got nothing going on except 87888 this week. We will do our first chapter review on Friday, and then we'll take our chapter test on Monday. Okay. Here's your homework tonight. There's only 9 problems.
9.
All of them say, write the equation, solve it. They don't say, what is the answer? They say, write the equation and solve it. So tonight for homework, you're going to write an equation, you're going to solve it. It's not that bad. Well, it's going to be more word problems, yes, but they're not that bad. The more word problems that you do, the easier they tend to get. The kids that never attempt word problems, which is why when you get to high school and they're more challenging word problems, you really, really get upset because you're afraid of word problems. The more of these you do at the lower levels, the less afraid and the easier that they'll be. Plus the fact that math teachers are boring, we don't have a good creativity. All of our word problems end up looking alike. Like the same word problems that you see in 7th grade, they just apply that to a 10th grade problem. We're doing these in Algebra 1, we're doing these mixture problems. I'm like, this is just a 7th grade problem, just written up so that you have to solve it the way a 9th grader would solve it. But it's still the same problem. Say again? 9th graders have issues, right? Let's just leave it there. All right, translating problems into equations. So I'm going to give you a whole, you can see in front of you, a whole bunch of sentences. You write an equation. The only thing it doesn't say here is that you solve the equation. I am going to suggest, and it is a suggestion, not a requirement, to, if you can, always draw pictures. To always draw pictures whenever you're doing a word problem. To always draw pictures. One at a time, please. All right. So word problems, draw a picture. Now, your picture may be detailed, it may not. And by that, I'm saying it says you have 3 bears. Some people would just love to draw 3 bears. Me, guess what I'm going to draw? 3 squares or 3 circles, right? But I don't want you to get discouraged from drawing a picture because, well, it would be too complicated to draw that picture. And put a dot and say this is the building. You don't have to actually draw the building. Put a dot. It can represent the building. But the picture, we're a visual species. We like looking at things. Pictures will help you arrive at understanding. Or at least that's what I'm going to hopefully show you today. Once you draw your picture is what helps you get to writing the equation. Because you'll be able to look at the picture, look at the question, and try to figure out what they want you to do. All right, here we go. So recall that when you wrote an expression, chapter 1, right, a sum of a number and 4, you wrote the expression. Recall the only difference between this and what we did yesterday was that there is now a equal sign. So when you write an equation, we said to look for the word is. The is your equal sign. Sometimes that's helpful, and you saw last night in homework. Sometimes there's not an is. Now you got to really just read it and have it make sense to you. The picture is what helps it make sense. Okay, but yes, if you see an is, it's the equal sign. We could solve this one, Madison. We would to both sides, and we get to an answer. Very good. Okay, so it becomes more challenging is when they take this simple problem and they make a scenario out of it. I had some candy in my pocket. My mom gave me 4 more pieces. Now I have 10. how many did I have to start with? Okay, that's pretty simple one, but that's what we're basically the idea there is that they're going to take this simple equation. They're going to write some scenario that describes that, right? They're going to give you the scenario. They're not going to give you the x plus 4 equals 10. You got to come up with the x plus 4 equals 10 and then solve it. And then, by the way, most of these are, for a lot of students, fairly simple. The students that have problem reading, draw a picture. It will help you. Trust me on this. So I'm going to do first example, and then we'll do 6 together. My numbers are all jacked up. I think my last one they call example 5. It's not. There's six examples, and this one right here. Okay, close reading. Nathan, first sentence, read.
The perimeter of an isosceles triangle is 40.
Step number 1 is you got to understand what each word there. And I don't mean like the, but the key words there. Pick out a key word. Tell me what it means, Nathan.
Isosceles.
How about perimeter is the first one? What does that mean? Distance on the outside of a shape. If it was a circle, it would be circumference. If it was a polygon, then perimeter is add up all the sides. Yes? That shape, we know what a perimeter is. Next key word.
Is isosceles.
What the heck is an isosceles triangle? 2 chapters ago. You remember?
Isn't there a triangle that has the one equal side and 2 unevens or all uneven?
1 equal side would mean all 3 are different.
Would mean there were 2 equal.
Yeah.
So maybe 2 equal sides.
Also, I forgot to put my name on my homework
Uh,
because it came from inside my notebook. Could I?
pass that back to him. Find it, put your name on it. For those of you that, well, hopefully you don't realize it now, but I have quite a few papers that have no names on them. This is an entire year's worth, right? But every one of these kids right here has gotten a 0 on their homework because they're like, well, I don't know, I turned my homework in, I assume you put it in the grade book. You don't put your name on it. This is from yesterday. Here's one from your class that got a 0 yesterday, right? Because there's no name on it. I don't know. That could be the other one. So this is why I always encourage you to make sure you have that password for Power School and you check your grades. Hey, you gave me a 0. I know I turned in my homework. Well, before you even say that, walk your happy butt over there, look through those papers, and see if you can find yours. Right? I'm just gonna say I do make mistakes. You see me make math mistakes. I don't screw up grading ever. Right? I mean, I guess the only possibility is if there was gum or something stuck and I pick up 2 instead of 1. But I mean, I will feel that. I don't make a mistake on grading. Right? They go in the basket. I put them on my desk. I walk down at lunch and I grade all your homework during lunch, right? I don't make that mistake. But what can happen is if you forget to put your name on, right? Or you forget to actually turn it in.
Okay.
But yeah, but I do highly encourage you guys to check Power School. And that's kind of the only way you're going to know that hey, you got me as 2 missing assignments. Somebody here, who was the last person who got a no name? I said, go check the no name file. Oh, here it is. Right. All right, back to our problem. So we've got perimeter, distance around. We got the shape. It's a triangle that has how many equal sides? Because it's isosceles. How many? 2. And we know that the perimeter is 40. So I'm not saying you have to draw a picture, right? But it can at least get you to some understanding. So I need to draw what kind of triangle? Isosceles triangles has 2 equal sides. So here's a triangle that has 2 equal sides. The left and the right are same. Do we know how long each one of these 2 sides are? The 2 sides are the same. Do we know how long they are?
No.
So guess if you don't know what you put.
X or some sort of number.
Some sort of variable. If you don't know what the number is, you put a variable. Okay, I could choose X, maybe L for length, right? It's your choice. Do we know the third side? Do we know the third side?
No.
Read.
It's 40.
Oh no, that's the perimeter.
16.
Where are you getting that from?
The end of the question.
It literally says the third side is 16. So yes, I will insult you and say, read the whole thing. Yeah, I asked you to read the first sentence, but read the whole thing as well. So we know that the third side is my picture correct now? What's the only bit of information I haven't used so far? What have I not used?
The perimeter of the triangle.
Well, that's there.
The one.
The perimeter,
I've got 16,
the first state.
which is,
The perimeter
The
of
perimeter
triangle
is?
40.
have I used that yet?
No.
Do you see the number 40 up here?
No.
Who can come up with the equation that relates this picture to 40?
40 minutes.
That's not the equation. Perimeter means what?
It means the length of. No. hold on.
Nathan?
It's the length of the outside.
So then what would be the equation if these are the sides? Don't overthink it, just say what you see. You're overthinking it. You told me it's just the sides added up. So what's the equation? Connor?
Well, L plus 16 equals X or something.
No. We know what it equals.
X. Oh, 40. So L plus 16 equals 40.
Yes? Why do we draw the picture? Because the picture allows us to say, oh, the perimeter has the sides that are listed here, and perimeter is all the sides added up, and we're told that it equals 4. Was that what you were going to say? I think what he was trying to actually solve it, which is why he said subtraction. We'll eventually subtract. You were trying to solve it before you wrote it. Okay? And even though that might have been the correct equation, I wanted you to write the equation for you. So, like I said, some people are thinking ahead already kind of know what this is going. Hey, by the way, if you have an L and another L, how many L's do you have?
2.
See what I did? I mean, L plus L is 2L. I have 2 of them.
2 times L.
By the way, if this was L plus 3L, how many L's would I have?
3L. I mean, 3L. It would be
If I have an L plus 3L, how many L's do I have?
2. 4.
4L.
Where are you getting a 2 from? If this was 2L plus 3L, I would have. All right, that's how that game is for me. We'll learn about that next year. All right, but yeah, L plus L is 2L. Okay, does this look familiar? Can you solve this? Step 1, how do we solve it? Okay, you guys remember we're either going to get rid of the 2 or the 16. My recommendation was always get rid of first, except next year one exception. So let's subtract 16 from both sides. Look familiar? 40 minus 16 is
Isn't it 32? I mean 34.
24.
last step.
And then you
Divided by 2.
2 by 24.
Therefore, one of the congruent sides is equal to,
12.
and you are done because that's what it said. What is the length of one? This one of the sides is L, right? And we just figured out L is equal to 12. We're done. Are there any units here? There's no units, and if there were feet, centimeters, inches, that sort of thing. Okay, so tell me, what are the steps to solve this problem, not the equation? What are the steps?
So we're solving this again, right?
No, I'm just saying, in general, big picture, what were my steps?
First, you read it.
I read it really carefully. Step 2,
You find the is, right?
if there is one, right?
Then you look.
And by the way, there is one.
Well, then you read the rest of it, and then you make a picture.
Picture. Second
Then-
step. After reading it, you draw a picture.
Then you make an equation.
Then I make an equation, and
And
then
then you can simplify the equation.
I solve the equation, and you're
then
done.
you solve
There are
it.
your steps. Read, draw, write, solve. I guess a fifth one would be answer the question, right? As always. All right, question what we just did. If you know what you're doing, try box 1. Okay? You know what you're doing, try box 1. If you don't, let's do it together. Here we go. John, read the first sentence.
Well, like the perimeter of a hexagon is 97.
Hey, we just had the word perimeter. Jake, what does the word perimeter mean?
And it's
What does perimeter mean? It was the problem we just did. What's perimeter mean?
Area.
Area is not. Area is how much stuff is on the inside. If I ask you to walk the perimeter of the school, what am I asking you to do?
walk the outside.
So what's perimeter mean?
Outside?
Outside what?
Outside of
Is it a bunch of money? Is it a temperature? What's perimeter? Is it money?
No.
Is it temperature?
No.
Is it liquid?
No.
What is it? It's not area. Area is how much stuff is on the inside.
The perimeter of an area.
No. Well, no. I'm not going to go with that. There is a perimeter to an area. That's true. If I say walk the perimeter, what am I asking you to do? Eat? When you walk, what are you measuring? So what is a perimeter? I'm not mad. I'm just being animated. What is a perimeter? Thank you. All right. It's the distance around an object. That's all it is. All right. Hopefully you remember that. All right. So perimeter means distance of what's the shape?
Hexagon.
All right. That was 2 chapters ago. What's a hexagon?
It's 6.
Okay. You remember how to draw it?
Oh, yes, I
Okay.
didn't have to do anything.
To draw a hexagon, you draw 2 sides, one above the other, that are exactly the same. And then you put 2 dots. The first dot between the 2 lines, a little bit away from it, and the same distance away on the other side. And then you connect the dots to the sides, and guess what you just made? I got a hexagon. Oh, mine are never perfect, which is why I will use PowerPoint to make a perfect hexagon. There you go.
That's talent.
There's my picture of a hexagon. Hey, it says the perimeter of a hexagon is 90. That means all the way around this sucker it's 90. Do we know how much each side is?
Yeah.
Where does it say that?
I know it just says all the sides.
But it says all the sides are the same. So does it tell us how much one of them is?
No.
So, Maddie. Oh no, yes, but before we get there, and we don't know, what do we put? No, before that. I don't know what it is, so what am I going to write?
Oh.
Absolutely not. Do you know how big it is? And I don't mean do you literally know, I mean, before you solved it, did you know how much it was?
No.
So what do we put on a picture if you don't know? In algebra, when you don't know, what do you always do?
Or variable.
That's what she said. All right. Now, yes, and I'm going to go back to what I said at the start of class. Some of you can do these pretty quickly without drawing a picture. This is not that class. It's a class on what do you do if you don't know what to do. You don't know what to do, you draw a picture. You label what you can. Jake, if this side is X, how big is that side?
X.
How big is that side? In fact, they're all.
X.
What was your question, Jake?
Can I get the map?
No, let's solve this one first. Okay, bless you. Now use some hand sanitizer. All right. All the sides are at, yes, Maddie's already, some of you have well too. But I'm just saying, if you don't know what you're doing, this is your steps. Okay, we got to get an equation out of this. We go back to, Jake said that the perimeter is a measure of what? What was the perimeter a measurement of? Well, how far is it around the shape? Yeah, but we just wrote it as this plus. So how many of these do we have? So in other words, if I really want to write the long method, I could write that, correct? But I know how many x's I have. How many do I have? Now I'm going to take a step because I'm losing some people. I got some people saying, wait a minute, wouldn't I just divide by blah, blah, blah? Remember what this was an explanation of. I don't know what to do. So when you don't know what to do, you draw a picture. And you continue working at the picture, setting up the equation until you finally get to where you see, oh, now I know what to do. For some of you, you reach that point quickly. For others of you, you still might not be knowing what to do. But you should all be able to at least get to this point right here. Oh, it will be 6 sides of length x, and that has to equal 90. Are we okay?
Yeah.
All right, go ahead. Finish it, Danny.
Is it like, I was gonna ask.
Well, let's finish it. What do we do now?
We have to
Okay, how do we do that? Divide both sides by 6. Maddie already blurted out the answer, which was 15. And by the way, it has units this time, 15 centimeters. So when you divide 90 by 6, you get 15. Jake? Yes, you may go. All right. Questions? Yeah,
Do
Danny.
we do these same steps and the professor was just asking what's the length of one side?
Well, that's what the question was. What is the length of one of the sides? Now, fourth and final time. There are people here that already, right from the very start, just read it like, oh, I just divide by 6. There are other people out there that were like, I don't know what, I mean, they're sitting here among you right now. They're like, I don't know what to do. I need help. Hey, here was the help. You draw a picture. You label what you can. You reason through the picture and the words. You eventually get to an equation that you can solve. Like I said, I usually have kids right in their mind, like Caitlin is right now. Like, oh, this is stupid. All I do is divide originally from 6. Yeah, but that's just this particular problem. A more general problem where you get to where, like test day, you're like, I don't know what to do. I'm going to fail. This is what you fall back on. Draw a picture, write an equation, solve it. Next one. I don't know where my numbers go wrong, but at some point my numbers go bad. Once again, this is not a hard problem to do, but for some people it is. So I'm trying to show you a method of solving it when you don't know what to do. All right, who am I picking on? David, read. That's pounds. LB is pounds? Where's the P? Anybody know why pounds are abbreviated LB? What? You're very close. What do we make you do for 4 years at this school? Take Latin. So guess what LB actually is? Pounds in Latin. In England, they don't use the euro, they use pounds. On our money, if you pull it out, I don't have any money on me because it's the 21st century. Our money has that symbol. That means, and at some point this year, I'll explain why that means dollars. But guess what the money looks like in England? Guess what it has on it? Doesn't it?
It's like this.
It's got an L and a B because that is Latin for pound. I believe the word is librium, but I could be wrong on that. But it's something like that. All right. If we have time, I'll look it up. All right. Back to our question. Read, David. Jennifer, about 5 pounds. What's the price per pound? Now, I have plenty of kids that will look at that and know exactly what to do. But I have other kids that will look at it like, I don't know what to do. So what's Mr. C's advice? Talking about myself in third person. What's my advice on all word problems? We just read it. Now what?
Picture.
I gotta draw a picture. Okay. It says, what is the price per 1 pound or per pound? I'm going to draw a box. And inside my box, guess how many pounds I'm going to put in? Do we know how much 1 pound costs?
No.
So guess how much it costs.
It costs like something.
So guess how much it costs.
99 cents a dollar.
Guess how much it costs.
$3.25.
Connor. It costs X because I don't know. Once again, this is how you solve it when you don't know what to do. Some of you probably already know what to do. How many pounds are here?
1.
How many pounds do I need here?
5.
So how many of these do I need?
5 X's.
Okay, that gets kind of cumbersome, right? So if I add up all my X's, I would have
5X.
and that would equate to,
5 pounds.
and we know that 5 pounds cost.
3.5.
So what's my equation?
Well,
All we're doing is adding this up.
5 equals 345.
Oh no, 5 what?
5X equals 345. 3.45.
You see what I mean? If you draw a picture and you don't know what to do, you can get to what you know what you can get to what you should do. I said it right that time. Okay? Question? No, we're done with bathroom breaks, people. Bathroom breaks are for breaks And for not during class when I'm teaching. That's why you get 5 minutes of passing period. Pass your fluids during passing period. All right, to be disgusting. All right, no, I'll let you go here in a second. But let's try to limit our bathroom breaks to natural breaks in the class, not during class. All right. Tell me what to do to both sides.
5, 5, 5.
Okay. And if we divide that by 5, who's got the answer?
I do.
What?
It's 0.6
What does that mean?
x equals.
What does that mean, though, in this problem? And you were right, by the way. Yeah, but what does it mean? What is it asking?
What's the price?
So what's the price?
69 cents.
69 cents. Okay. Did everybody else get that?
Yeah.
By the way, math teachers have a heartburn on this. Because what does this actually say?
69 cents.
But no, it doesn't. It says 0.69.
This 0.69
Ah, and that's the issue, minor issue. If I say 69 cents, I can't use that symbol. I have to use the cent symbol. The cent symbol is a C with a line through it, right? If I use the dollar symbol, it's 0.69 of a dollar, that's 69 cents. Okay. C, not S.
No, but the dollar sign.
Oh, yes, yes, yes. The big question is why, right? All right, I'll explain it to you one day. What?
One day.
Why is the dollar symbol an S and not a
Just
G?
literally just said I will explain to you, just not today. All right. Example number 3. Now, some people get lost because they don't deal with banks. They don't know what the words mean. If you ever, at least in my class, except for state testing, you take a test and you're like, I don't know what that word means. You just ask. All right. Nelius, read.
Henry withdrew $150 from his bank account. He had $10,150 left. How much money was in his bank account before the withdrawal?
Now, some people can look at this problem and immediately know what to do. Other people look at it like, I don't know what to do. This explanation is for them. What's obviously my suggestion?
Read.
We just did.
Then draw a picture.
We're going to draw a picture. This time, pun intended, this applies itself to a timeline, right? Because it says he does this, then he does this, and then what happens at the end. So this applies to a timeline. Macy, according to the problem, what's the very first thing that happens?
Withdrew $350.
So that means that you need to know what withdrawal means. What does withdrawal mean?
Take out,
What is the opposite of withdrawal according to banks?
adding, or.
No, there's no adding a bank.
Wait, what do you call it? I got it.
Exactly. Say it.
Depositing.
Depositing is the opposite of withdrawal. So occasionally I get kids like, I didn't know what that meant. No, hopefully now you do, or you'll remember to ask questions. You put money in, you add money to your account, okay, but they call it depositing. Yeah. Let's get to the end. Okay. All right, so if we did a timeline, where's the start? He walks into the bank. So at time 0, he's got a certain amount of money. How much money does he have?
1,500.
Oh no, that's at the end.
He had.
How much money does he have at the start? We don't know, so we're gonna put.
Variable.
Now here's my picture. Now, granted, I did it in PowerPoint.
Money.
I'm not gonna draw literally a pile of money. I'm gonna put a circle or something or a box and put start. What's the next thing that happens, Macy, after the start? Okay, so mathematically speaking, what's a withdrawal?
You took something.
So mathematically, that means what?
Minus
What are we minusing?
$350.
Okay, he did a withdrawal. Mathematically, that means minus 350. Here's my picture. It's not much of a picture. Well, what happens after the withdrawal? Just read it. What does it say? What happens after the withdrawal? He has, or had is a, I don't know, conjugation of the word to be, and that's the word is. So guess what I'm going to write? Equals what? What? Read the number. Thank you. Well, there you go. To finish, you've got 1,150. Okay. Do we have an algebra equation?
Yeah.
Once again, there were people that could have looked at this problem at the very start, like, I don't need your silly algebra equation. I know what to do. But there's other people, they're all around you right now, have no clue of what to do for problems like this. So my point being today is draw a picture. Every one of you that answered on that question said it right the very first time, knew exactly what to do. I guided you through that problem using a picture. Macy, what do we do to both sides? Plus what?
300.
And we get to an answer, and that's your final answer. So he had what?
$1,500.
At the very start. Okay.
There's no way that's
Well, if that's in $1 bills, it could be.
Oh yeah.
If that's in $10 bills, no. All right. What?
It's in $100.
$100 bills, that's a million right
What
there.
if it's like
$1 million bucks can be fit into a box this, by that.
If you're using $1,000.
There are no $1,000 bills in current, in circulation. There are, but they took them all. The highest bill is either 100 or 500.
Why did they get rid
Yes.
What about $2?
All right.
They're still in circulation.
You got the next one done? Got the next one done? Do that one and then go. All right. Here we go. Now, once again, some of these problems are more challenging simply because of the vocabulary they use. All right. Show me with your hands what does width mean. Show me with your hands what width means.
Width or width?
Show me your hands what length means. Okay, so that right there is going to get you into problem this one because what's the shape we're dealing with? A road. So it all depends in your mind which way the road goes. Jake, we'll use Jake. When you think of a road, which way does the road go? Up and down or left and right? So his road goes left and right. When I think of a road, my road always goes up and down.
North, south.
Right? There's no, and it could be either one, but I'm not going to show you both. I'm going to show you the example where the road goes up and down. So if the road goes up and down, where's the width?
Up and down.
So if the road goes up and down, the width would be left and right. Right? The length would be of the length of the road would be up and down. But on Jake's, if his road goes left and right, the width would be this, and his length would be that. I'm just going to say width and length can get you into problems. Make sure you think it through. It says a road that is 8.5 meters, not miles. The abbreviation of miles is MI. A road that is 8.5 meters wide is to be extended to 10.6 meters wide. What is the width of the new paving? That's why we went to that whole thing about what's width and what's length. I'm going to draw a picture. What's my picture need to be of? A road. So a road is basically what shape?
A rectangle.
There's my road. Notice where's my width? Left to right or up and down on my picture? So how wide is the road at the start, according to the scenario?
8.5.
There's my 8.5. What are we doing to the road? Are we making it longer or making it wider? Where do you see that? Where do you see that? So in my picture, am I increasing up and down or am I increasing left and right?
We're making it taller.
That would be distance. This is what I'm going to say. This is a confusing thing. And if somebody gets it wrong, it's because they couldn't draw a picture of this. And clearly that was a mistake right there. 8.5 is how wide the road is. This is how long the road is.
Long up or something? Or like
Picture a road in your head. Which way does your road go?
up and down.
Okay. So length of the road. Hey, I went 1 mile, 2 mile, 3 mile, 4 mile. There's length. The width of the road would be left and right. You're doing 3 dimensions now.
Oh, okay, I get it.
Thick would be different.
Okay, so the road is this tall, but the road is this big. You can extend it to be this big.
Okay, so we need to extend it up and down or left and right.
Left or right?
By how much?
X, because we don't know yet.
Because we don't know. So there's I don't know how much, right? But I know that green would represent making the road wider. Does everybody get that? Does everyone understand why this one can be confusing simply because of using the words width and length? Okay. By the way, once the road is finished, how wide is it?
10.6.
So where do I write that on my picture?
Well, you can write it, I'd say.
Write it on the side.
The side would be the length.
The bottom, the top. Cross out the 8.5.
Now, I want to leave that because that's how far the blue is.
Make a new one and then.
Just write it
So
right.
mathematicians will do this, right? They will put little lines that indicate that it is the entire length, or entire width in this case. That make sense? It does. Okay. By the way, how big is this little tiny green piece? How big is this?
2.1.
We don't know that yet. How big is it? Yes, you're right, but we're not yet. But we don't know it. We're at the start of the problem, so it's an X, right? So there is my distance. Not next, all right. Remember, I started off the class by saying there are kids that will be able to do this whole thing in their head, and there's other kids that have no clue of what they're doing. This class is for those kids. Okay? All right. Somehow we got to get an equation out of this mess right here. What's the equation?
The equation would be 8.5 plus x equals 10.6, right?
Agree or disagree? That is the equation. Now, Carson, what do we do to both sides?
We subtract 8.
Which is why Carson said a minute ago that the answer is 2.5 what? Meters.
Oh, good.
Okay?
I got that answer actually.
I'm going to warn you some of the easiest problems, only because this one uses the term width and length, can become confusing. You have to think it through in your head. How long did it take you to draw this picture? No. Took me 20 minutes to probably explain it. How long did it take you to draw the picture?
Forever.
About 5 seconds. You got 5 seconds when you have a word problem.
You can just draw 2 lines. Basically.
All right. Example number 5. Oh, that's where I went on. All right, here we go. We have a 20 story. What the heck is a story?
How many
Floor.
levels?
Levels, floors, right? So we have a 25 floor, 25 level, 25 story building. The total building is 105 meters tall. What is the height of each story if they are equal? Now, once again, there are people that can look at that and know exactly what to do. There's other people who look at that don't know what to do. So, Caitlin, if I were to draw a picture of this, what would I do? Because the rectangle is going to represent,
You gotta draw little windows.
yeah, and that's where all of a sudden it does turn into a 20-minute problem. But I'm going to point out that even though we're talking about a building, we're really talking about, according to the problem, we're talking about 1 story. We're really not talking about the whole building. We're talking about 1 story. So guess what I should really draw? 1 story. If I draw 1 story, here's my rectangle. How tall is it? Oh, by the way, it's 1 story. How tall is it? Because we don't know, we assign a variable, therefore it's x is feet, no, meters tall. Yes?
Yes.
How many of these do I have?
25.
Oh dear Lord, do I want to draw 25?
No.
I might draw 2 and stop right there. But I do realize that there's 25 of those. So what's, I could. So what's the equation?
25x equals 105.
So 25 of these added together, if each one is x, then that would be 25 x's.
You can just put plus 25 on the top.
And that not plus, but times, because there's 25 of them. And they're all the same. So x plus x plus x plus x plus x plus x, 25 times. That's 25 of them. Therefore, this is actually a pretty easy problem. Now that I drew a picture and I can wrap my head around it. Other people don't need to draw the picture to wrap their head around it, but some people do. That's what this class is for. It's for the people that say, I don't know what to do when I get to a word problem. Read it, draw a picture, understand your picture, write an equation, solve it. By the way, what's the answer here? What's the answer?
Well, don't you divide it first?
Okay, so what are we dividing by?
Are we dividing it by?
We need to get x by itself. Hey, Nathan, where is your
So
stuff?
25x divided
4.2.
Get it all out. Okay, you are the last one to leave
I
today.
forgot. I forgot. I'm supposed to do it. It's 25x divided by something. Oh, wait.
We're doing algebra. The goal in algebra is to get x by itself. Where's the x? Left or right side? What's attached to it?
And left side.
What's attached to it?
25.
How do we get rid of 25? So you get rid of 25, then x is by itself. How is 25 attached to x?
By times.
How do we get rid of multiplication?
10x division.
What are we going to divide both sides by?
Divided by x.
We're trying to get x by itself. So my goal is to take the magic eraser and erase 25. That's what I need to get rid of. So what are you going to divide both sides by?
That's kind of what I'm stuck on.
By the number
Oh,
you're
divide
trying
the
to get rid
number.
of.
Oh my god.
All right.
Okay,
So
well,
what am I gonna do?
25 divided by 25.
Okay. Did anybody already do that math?
Yeah.
What do you get?
4.2.
How much?
4.2.
4.2 snakes, monkeys, gorillas, what?
Storage.
No.
Meters.
Meters.
That's a really small building.
Well, remember a meter is 3 feet. So a little bit over 3 feet. So that's over 12 feet tall is one story. So how high is this roof? I'm shorter than 6 feet, and that looks to be about double. That's about a 12-foot roof.
You better off this building.
So it's about that tall.
It's a big skyscraper.
And 25 of these stacked on top of each other. Oh, there's where my numbers went wrong. Okay, last one. Does yours say, yeah, but I'm calling it example 5, it's example 6. Okay, last one. This is the hardest one. I will have people, if I put this on a test, not know what to do. So guess what you need to do? Draw a picture. What's the L mean? You have 150 liter tanks, you know, liter of water, like 150 of those in one tank. You have a 150 liter tank. It can be filled with a pipe in 60 seconds. That means in 60 seconds, the tank went from empty to completely full. How many liters per second? That means how many liters in 1 second has to go into the tank to make that happen. In 1 second, how many liters have to go in the tank so that in 60 seconds it's completely full?
X.
Okay. So before we try to guess, how about we draw a picture? What's the shape I need? Don't overthink it. A tank, right? A circle, a rectangle, a square, there's my tank. But here's where I'm going to show you how you're going to think of this wrong. This says, how many liters per 1 second do you need? So this isn't going to be 60. This is going to be how many seconds? It says, how many liters per 1 second? So how many seconds is this going to represent?
X.
1 second. It literally says, how many liters per 1 second? Per sec means 1 second. So this tank isn't going to be the full tank. It's going to be the 1 second tank. My question is, how many liters? That's what we don't know. If this represents 1 second, how many of this shape do I need? I need 60 of those suckers. I need 60 of those suckers. Am I going to draw 60?
Just put times 60.
How about we just write times 60? And I know what that equals because it tells me. What does it equal? It equals 150. I'll draw 2. How about that? But each one of these represents 1 second. In this 1 second, there's this many liters. X represents how many liters. In this 1 second, it's the same thing. So for instance, if this was, stop. If this was 2 liters, in 2 seconds, how many liters would you have? Here's 2 liters. Here is,
Oh, 4.
so in 2 seconds, you have 4 liters. Now the question is, if it was 2 liters, in 60 of them, would you get to 150? The answer is no, because 60 times 2 is, we don't have enough, so it's more than 2. So before you guess, how about we just do the math?
60x
So it would be the equation,
60x equals 150.
and then we solve that. So let's solve it.
2.5.
Okay, what do we do to both sides?
Divide by 60.
We're not dividing by 6, we're dividing in this case by 60, which is what Devin said. So if we divide 150 by 60, we chop the tree down, what falls on the inside?
150.
150. So we got 150 divided by 60. Does 6 go into 1? Does 6 go into 15? How many times?
Wow.
Yes, 6 goes into 15. How many times? Okay. But it's not 6, it's
60.
60. So 60 doesn't go into 1. 60 doesn't go into 15, but 60 goes to 150.
2.
6 times 20, or is it 2 times 60? Where is it? 120, subtract.
30.
Here's your decimal, bring down the 0.
2.5.
2.5 what?
Liters.
So if this has 2.5 liters, and this has 2.5 liters, and 60 of them, then it fills it up in 150. In 60 seconds. Your homework was right here if you did not copy it down. I will see you tomorrow. All right, any online learners? There is no one present, but if you do have a question, send me a chat or an email. I'll have it.